So this problem we're going to have to use the derivative for, I think. So what are we doing? Find the slopes of the tangent lines to the graph of f of x equals x squared plus 1 at those points. So first we should picture the graph, because it's always very helpful to picture the graph. So let's picture the graph. X squared plus 1. What does x squared plus 1 look like? Well, it's a parabola. More specifically, it's a parabola moved up 1. So that actually helps us for the first one, because at the point 0, 1, well, if it's at the vertex, if it's at the bottom of the parabola, we should really be able to see what that tangent line is. The tangent line is just going to be horizontal because it's at the bottom, right? And so what's the slope of that line? The slope of that line is 0. The slope of the tangent line at 0, 1 is just 0 because it's a horizontal line. Now at the other point, negative 1, 2, so like roughly that line, that we're going to have to use some calc for. So let's talk about what we're going to have to do there, because we haven't even talked about the derivative yet. So how does this go? So I guess I'm just trying to draw this bigger here. So we have our point right here. We'll call that our negative 1, 2. And then what are we going to do here to try to find the slope of that tangent line? Because we can't just calculate a slope of one point, right? That's the whole thing about the derivative. So what we're going to do is we're going to imagine this other point. Let's call that point just some x value. We'll call it A. So that's the point A, comma, we'll just say f of A, because notice we're using f of x. So just A, comma, whatever you get when you plug in A for the function. And we can find the slope between those 2 points, right? Like, that slope's easy to find. What's the slope between those 2 points? The slope between those 2 points is y2, so actually the y value first, y2 minus y1, which is actually just 2. So f of a minus 2, y2 minus y1 over x2 minus x1. So like that's our slope. That's the slope between those 2 points. So that's fine. There's nothing wrong with that. But then how do we get calcy with it? How we do it in calc is because we don't want that between the 2 points. We want to see what happens as we drag that point closer to this point. Because see, as we drag it closer, like we get that line, we drag it closer, we get that line, and by the time they're directly on top of each other, we basically just have the tangent line. That's the whole idea here. So what we're going to do is we're going to make that a value, so we're going to take the limit as that a value gets closer and closer and closer to the point that we care about, negative 1. And that's the idea of the derivative. That's really the whole definition of the derivative. So how can you write that out as like a point or as like an actual equation? What is it? We sort of use different variables, I think, than normally people would use. So I think normally they do the limit as x approaches a, whereas this is f of x minus f of a over x minus a. So that's the same thing that we just did. But anyway, let's just do this out now. So just calculate this. So what is f of a? Well, we know what the f function is. The f function is x squared plus 1. So let's move this over here so we got more room. So we're going to do the limit as a approaches negative 1 of a squared plus 1, because that's what f of a is, minus 2 over, that ends up to be a plus 1, because minus minus. Okay, that's beautiful, because then what can we do from there? we have the limit as a approaches -1 of a squared minus 1 over a plus 1. And see, this is where your algebra comes in. Because how do you factor a squared minus 1? That should be second nature at this point. That's going to be, so just go ahead and copy this down, a plus 1 times a minus 1. And since that's divided by a plus 1, you see how that just cancels. And so now we have the limit as a approaches -1 of a minus 1. And now we just plug it in. And so it's -2. So the derivative, the slope of the tangent line at that point is -2. That's what we just calculated. So to review again, what was the big idea? Because that's almost the important thing. That's our main point we cared about. This was the other point we were looking at, and we thought about what happened as we dragged that point closer and closer and closer. As you see, when it's there, like that's our tangent line. When it's like we move it closer, if it's here, then that's our tangent line. And as we move those points closer and closer and closer, it got closer and closer to the tangent line. And that's the idea of how you calculate the derivative.